Boom, we are good to go. Welcome to Taco Tuesdays Math, Algebra 1. Once again, my name is LeBron James. I'll be running this show with the rest of you all. So we'll be able to get some good learning in. So first, let me go ahead and put my PowerPoint up so I can drop a little knowledge on y'all before I start taking your questions. Bam, so here's our PowerPoint for the day. Once again, Taco Tuesdays. I'm glad that everybody was able to come out and make it again. What I want to do first is before we get started with the presentation, I want to take a poll sort of to get your advice on how you guys are feeling about math. So let me do this poll real quick. So we have two questions here for you to answer. The first question is, how do you feel about math? Either do you love it? Do you just like it? You could take it or leave it. Do you hate it or do you fear it? So if you can go ahead and put in your answer to the first question, I'd appreciate it, and click it. Can everybody see the poll? Okay. Hold on, Angelina, I see your hand is up.
Wait,
okay.
yes. So wait, where's the poll questions? I can't find them.
Okay, it should be right on the screen. You don't see it right on your screen?
No.
Okay, hold on one second. Tell me if you see it now.
Yeah, I see it.
Okay, perfect. Thanks, Angelina. I appreciate it.
Okay.
Great. We got almost half the people giving an answer. Almost there, okay. So we can answer questions 1 and 2. I don't know if you can see all of 1 and 2. So basically, we want to know, how do you feel about math, and then how do you feel about your math teacher? Okay, I think just a couple more people. Yeah, we almost got it done. Okay, fantastically. We had just about everybody. So looking at how do we feel about math, we could say that it looks like most people are like, okay, I can take it or leave it. It's not too bad. A couple people love it. One person fears it. A couple people hate it, which is about normal. And like, how do you feel about your math teacher? Okay, I like my math teacher. Cool. I'm glad the majority of you like your math teacher. That's good. We've got 5 people who don't like their math teacher, which is pretty normal. And even a couple of people who said their math teacher is their favorite. Okay, cool. So I just wanted to take a little survey to sort of see where we are. So now I'm going to go back to the PowerPoint here, so you guys can see the results here. So for most of you, you said, hey, I can take it or leave it. No big deal with the math. And the majority of you say that you do like your math teacher. So that's cool. All right, so now we'll get back to the PowerPoint here. 1 second. Go. So once again, I'm not sure how many people are new. For all the people who are new, welcome to the class. For those who are coming back for week 2, thank you for coming back again. So I'll just do a quick overview, then we'll get into the problems here. So first, if you're asking, okay, who's this black man on my computer trying to teach me math? Just so you know, my name is LeBron James, not to be confused with some other guy who's not playing basketball right now. But I have a degree in mathematics from UCLA, and I also have a master's in education from Harvard. I was a classroom teacher for 15 years. I've been doing this for a long time. And I actually been teaching online math since 2001, which is before all of y'all were born. So I know I look good for not having hair. You can't see the gray because I'm bald. So I'm just letting you know I'm much older than you think. So anyways, The first thing I want to tell you all about online learning is you have to master something called BCBU. Hold on a second. BCBU, that's not a historically black college. BCBU simply means being comfortable, being uncomfortable. So in life, as you progress in life, as you try new things, as you become smarter, as you go to high school, then to college and your career, you're always going to be uncomfortable at some point. You have to learn to just be comfortable being uncomfortable. So if you're not used to learning online, just say, you know what, this is uncomfortable. Maybe I've never tried it. I'm not comfortable with it yet, but just be comfortable being uncomfortable. And as you progress in life, keep in mind that if you're really comfortable, you ain't doing enough with your life. So you should always be striving to do more, achieve more, be more, help more people. And so when you are doing more in life, you will start to feel uncomfortable, and that'll be your signal to let you know that you're doing the right thing. Just want to share that little knowledge with you guys real quick. Also, all math from kindergarten through calculus is only two things: patterns and relationships. So if you see a problem and you're not sure what to do, the first thing you want to ask yourself is, what is the pattern that's happening with these problems? And then what's the relationship? How are these two things or three things, how are they related? So keep that in mind, especially when you're doing algebra and above. Look for the pattern and look for the relationship. So now I just want to give you a few success tips in algebra. Like I said, I've been teaching algebra for over 20 years. I've had most of my students going to Ivy League schools, UC schools. I've helped athletes who are not eligible go from being ineligible to being eligible by making algebra simple, fun, and entertaining, which I'm trying to do. So here's a few tips I want you to take away about how you can achieve success in algebra. The first thing, if you don't know your times tables, or you struggle with your times tables, or you feel that you may go slow with division, or you don't add or subtract too fast, use a dang calculator. Now, some of the teachers may not allow you to use a calculator, but don't worry about them. Use the calculator so that you can quickly get through the problem, because you want to develop your thinking skills, and you don't want addition, subtraction, multiplication, and division to get in the way. And after a while, you'll start memorizing the multiplication tables from putting them on your calculator. So the reason I tell people to use a calculator is because when you get to high school, you're going to have to use a calculator anyways, usually a TI 86 or 89 or something like that. So just get comfortable with your calculator. Second thing, whenever you're trying to find X or solve for X in any problem, just remember you're trying to undo what's been done. Always think opposites. So if I see addition and multiplication, then I'm thinking I'm going to have to use subtraction and division to find X. So remember, if you're always trying to think about algebra, it's always about the opposites, because we're always trying to get balance. We're always trying to balance things out. All right. Number three, if a problem is really complex and you don't know how to approach it, rewrite that same problem in a simpler form, and then you'll be able to solve it. So that's the goal. So write something that's complex in a simpler form, and then to go ahead and solve it. And I think, let me see if I can give you one example of this. I think this is gonna let me annotate here. So I'm still getting used to the online environment as well. Oh, so number four, let me see if I can annotate this real quick. Just gonna let a brother write. Oh, there we go. So for number three, a complex problem. So if I had 2 square root of x to the 5th minus 9 square root x to the 5th. If I don't know what this means, I would say, okay, let me rewrite this as 2y minus 9y. I just took away that crazy radical and exponents. I just took that stuff out and replaced it with y. So now I know 2y minus 9y must be negative 7y. So I took a complex problem and made a simpler version of it. So now I know if this is what happens here, then for this one, it would just be a negative 7 square root x to the 5th when I replace the difficult part back in. So I just wanted to share that with you guys real quick. Number 4 here, hurry up and fail. Oh, this is so key. The only way you learn and succeed in math is you have to do a lot of problems and you have to be wrong. So don't be afraid of being wrong. Hurry up and fail so you can hurry up and learn. And then you'll level up to the next level, just like playing video games. The only way you get better at video games is you play over and over. You lose, you lose, you lose, you lose. You finally win to get to the next level. Then when you get to the next level, you start losing all over again. So it's the same thing with algebra. So if you want to learn, hurry up and fail. So now the next part here, we want to go back here. Okay, so now, before we continue on, I want to see, did anyone have any questions? So you can either raise your hand if you have any questions so far, or before we get started, or you can also write questions in the chat below. So the chat is also a place where you can ask questions. All right, so now we're going to talk about one particular math concept today. And then after that, I'm going to ask you if there are any particular problems you want to see me, the types of problems you want me to solve. So you can put those type of problems in the chat box down below, or when I come back here, you can actually raise your hand and then ask me the type of problem and I'll do it. But let me go back to the presentation real quick. There's one other part I want to show you. The first thing you need to know is that you are all mathematicians, and that's the one thing you need to know. In order to do well in math, you have to have a math swag. You got to have an attitude, just like if you're a top athlete, top dancer, top performer, you got to have attitude, you got to have confidence, you got to have a swag if you want to be good at math. And so I'm telling you right now, each and every one of you are mathematicians, and all it takes is hard work. If you outwork the person next to you, then math starts to get easy, and then you start developing that math swag. So here's a concept you need to know just for your life. This is probably the most important part of the online class, is you want to understand the 80-20 concept, which simply means is that 20% of the things you do will give you 80% of the results in your life. So if your effort is 20%, whoa, hold on a second. 20% of your effort gives you 80% of your results. So everything you do is not equal. So find a few things you're really good at, put your energy in that, and that will give you 80% of your results. And so in terms of algebra, here are the 80-20 concepts. Here's the 20% of concepts that you will learn in algebra that show up in over 80% of the problems. And so if you learn how to do these things here really well, algebra will be a breeze. Algebra 1, algebra 2, and higher levels of mathematics. But today, I'm gonna focus on combining like terms. Just I want to show you the concept of combining like terms. So what do we see here? We see a group of fruit. So we look at the fruit and say, okay, it's unorganized. So what can we do? We can organize the fruit. So we put the same fruits that are the same types of fruit together. Right here, it was all messed up and disorganized. What we decide to do is organize the fruit. Now the fruit is organized in your mind, what does that mean? Now we can count the fruit. We have 4 apples, 3 peaches, 1 strawberry, and 2 bananas. So notice, we simply went from the fruit to putting the number of fruit that we have. And so this 4, this 3, this 1, and this 2 are like the coefficients. They tell you how many you have of each. Boom. And now we can translate that right to algebra. So we see if we have 1, 2, 3, 4 different types of fruit, that means we have 4 different types of terms. We have the X term, which goes with the apple, the Y term, which goes with the peach, the Z. You see the 1 strawberry means we have the 1 Z. So we always know there's always an invisible 1 in front of any number or variable if we don't see it. And then the 2 just represents regular numbers, 2 bananas. Now let's look at this fruit. So then now we have some more fruit, and this is a little different because now we have apples, but we have 2 types of apples. So how do we organize these? Boom. So we break it up now into strawberries, peaches, and now apples. But now we have red apples and green apples. So the question is, what do we do with these? So now we separate them here into the types of fruit. We have the the 3 strawberries, 2 peaches. We have the 4 red apples, and then we have the 3 green apples. So just because they're both apples, that doesn't make them like terms, because even though the same fruit, they have different colors, as we can see here. So here we have 4x plus 2y plus 4z squared plus 3z to the 4th. So here, even though they both have a z, they're not like terms. Oops, hold on a second. They're not like terms because the exponents are different. One exponent is a 2, the other one is a 4. All right, so just as a warm-up, and then we get to the problems, I want you all to try these 2 problems at your desk. Try problem number 3 and number 4. And then I'll give you 1 minute to do those. And then I'll come back and I'll give you the answers. So try that for 1 minute. So I'm gonna go ahead now and show the answer to the first one. Boom, this is what you should have got for the first one. 5x plus 10y plus 4. All right, so I'm gonna go ahead and do the second one now, which is 9x squared y cubed minus 14x cubed y squared minus 2y. All right, so we saw those. So I'm looking to see, do we have any questions on those 2? Raise your hand if you got those problems correct. If you got 1 or 2 correct, let me see you raise your hand. Okay, I see a couple hands raised. Raise them again. Okay, there, I see, okay. So 12 people raised their hands, okay. Put their hands down now. If someone could, who didn't understand the problem, if you could raise your hand and share with us what you found difficult or what part was confusing. See if anyone's willing to raise their hand here. Okay, I see one hand up. Okay, you just didn't have enough time to solve it. Okay, that's fine. I probably didn't give you guys enough time. I was just trying to introduce it, but I'm gonna get Elijah. You can talk here. Elijah, go right ahead and share.
I didn't get enough time, but I didn't understand if you're supposed to like put the like terms like together or like.
Yeah, exactly. Great question, Elijah. Yeah. So the thing is, you want to put like terms together. So you want to look at when you look at a term, you want to see, does it have the same variable and the exact same exponent? So if the variable and exponent are a match, then those are like terms. So you want to add or subtract those together. So that's the idea, is to combine like terms. And we can try some more of these, like I said, when we go to the whiteboard. All right. Thanks a lot, Elijah. All right. So now what I want to do here is going to take it to the whiteboard and we'll start doing some problems. So now For those who have some particular types of problems that you would like to see, I want you to go ahead and give me some stuff in the chat about the type of problems you would like to see. I'm looking for some types of problems. The minus and positive operators are the negative and positive. Okay, positive and negative numbers, okay. And substitution and elimination method. Okay, perfect. So we'll start with positive and negative number operators. Then we'll look at substitution and elimination problems. So let me do a couple of the minus positive and negative operator problems, and then we'll look at substitution and elimination next, and then I'll get to those other terms. All right, here we go. Here we go. So in terms of dealing with positive and negative numbers, ooh, it's a little messy. I'll get warmed up in a second. So all you want to think of is, once again, you want to think of the same, all right? So we know that a positive plus another positive gives us a bigger positive number. And then we know that a negative plus another negative gives us a bigger negative number. But more importantly, think about temperature. All right. So if it's -6 degrees outside and the temperature drops another 10 degrees, that would put us at a -16 degrees because it was already negative. And then when we drop, that means going lower. So we would go to -16. So if you think of temperature, if we're, got a thermometer here. And this is 0 degrees. If we go up here to say 40 degrees, right? And then the temperature gets cold and it drops by 50 degrees. And the question is, where are we now? Where we are now is now we're going to be at -10 degrees because we started at 40, we dropped 50, so we went back that 40 to 0, and then another 10 degrees to get down to -10. So when you're dealing with positive and negative numbers, remember, if we add 2 positive numbers, it gets larger. If we add 2 negative numbers, it becomes more negative. And if a number is positive and negative, what we do is we take the big number minus the small number, and then whatever number you get, you give it the sign of the larger number, whatever the sign was on the big number. All right, so I'm gonna give you one more example of this, the way I would do it when I was in the classroom. So if you have Crips, you have Bloods. The kids in my neighborhood, they understood this real well. So if we have 18 Bloods plus 5 Bloods, it's real easy. You got 23 Bloods. Now, if you're Cripping over here, if you had 10 Crips plus 7 Crips, you would have 17 Crips. But now the question is, if you have 17 Crips plus 23 Bloods, what's really going down, right? So we have to look at the higher numbers. So they're not like terms. So then we have to do 23, the bigger number, minus the smaller number, 17, and that gives us 6. So then here, the answer is 6, but there were more bloods in the beginning. So in the end, there would be 6 bloods. So if there's any bloods and Crips out here, no offense, just using this. So we could also say, make these Republicans. And then we could make turn the Crips here into Democrats. So either way, it doesn't matter. You just take two opposite things and understand that if you have two or more of the same, you add those up together. And if they're opposites, you take the big number minus the small number, and it takes the sign of whichever one had the most when you began. All righty. So that's a quick lesson on positive and negative numbers. So I'm going to put a couple on the board, and I want you guys to try, and we're going to move on to the elimination method. Here we go. So I want you guys to, in this problem, in this situation, we're going to simplify. Ooh, that was ugly. All right, here we go. I'm just going to give you 3 of these. 1, 6 minus 15. 2, negative 9 minus 3. And number 3, negative 8 minus 7 minus 2. So everybody try these 3 real quick. And when you get an answer, as soon as you get an answer to number 1, I want you to put your answer to number 1 in the chat, so I'll know who's doing this. Okay, I see a couple of answers here. Okay, I'm seeing some answers. Okay, like what I'm seeing some negative 9s. So that's correct. I'll make sure we're on the same page. I see one question. I think who had the question here? Let me see. It said, why didn't So Yvette, I think I see your question, but why did it become subtraction if the problem didn't show minus or plus? Okay, so that's a good question. So Yvette, what we're talking about here is if you have something that's red and something that's blue, if we have opposites, the only way we can compare which one is more is we have to use subtraction. Subtraction is the only way to delineate when things are opposites. And then whichever one is bigger, say if the blues were bigger, then our answer would be something blue. So if you're adding numbers, that are opposite signs, which I use opposite colors, the only way to get the answer is to subtract the bigger one minus the smaller one to get that answer right there. All right, so bingo. So there's negative 9. So now if we can get people now to share, what is your answer to number 2? Okay, you guys already beat me to it, exactly. So for number 2, the answer is negative 12, very good. So we're heading to number 3 next. So if you guys look at number 3, tell me what you get for number 3. Oh, good job, good job. You guys are killing the game. That's what I'm talking about. Boom, so negative 17, boom, that's the answer to number 3. Bingo, bingo, bingo. All righty, good job. All right, so I know now, in the interest of time, we want to get to a few more questions. So I know we talked about the elimination method, the substitution and elimination method. Here we go. So I'm gonna do about 5 to 6 minutes on this elimination method because it takes a little time. Let me get a new screen here and we'll knock this down. Also, as a reminder to everyone, when I teach online, I've been doing this so long, I move pretty fast and I don't take lots of questions because I'm gonna send you the video link so you can go back and fast forward or go back and rewatch the part that you want to see again. And then if you still have questions, you can always email me after the class because it's a whole week before we do this again. So I can still offer some more advice and help afterwards. So if you don't get all your questions answered, or if you feel like I'm going too fast, it's happening on purpose because you'll get the video clip after this where you can go back and watch. So boom, so let's now look at the substitution and elimination method. Substitution and elimination method. I'm sorry, my handwriting is like elementary school. It takes me a while to get warmed up. Here we go. So if we have a system, these are used for systems of equations. EQNS is my abbreviation for systems of equations. Here's one thing you have to know. However many variables you have, that's how many equations you need. So if I have X only, then I just need one equation to solve for it. If you have X and Y, if you have two variables, you have to have two equations to solve for it. And if I have, for example, X, Y, Z, if I have three variables, then you need three equations to solve for three variables. So always know, however many variables you have, that's how many equations you need to solve it. So when you get to two or more equations like these, that's when you need systems of equations, because systems just means more than one equation. And to do that, we have two methods. There's the substitution method and the elimination method. And I don't have a preference. My recommendation though is if you are real comfortable with one other than the other, I would stick to one as much as I can, the one that you're most comfortable with. Although most of your teachers are going to make you use both methods at some point. But if you get to choose the one that's easiest for you. The first one we're going to look at is we're going to look at the substitution method first. So here's an example. We're going to want to solve this system. So equation 1 is going to be X plus 2Y equals 10. The second system is going to be 6X plus 5Y equals 2. So now, the substitution method. I always choose a substitution method if I have a variable. If I have a variable in one of the equations that has a coefficient of 1. So we don't see a 1 there, but we always know it has a coefficient of 1. So the first thing that I would look at both equations and say, oh, okay, this one has an X, which means it has a coefficient of 1. That tells me in my mind, oh, I want to use the substitution method. So what I'm going to do is I'm going to take equation 1 and I'm going to rewrite it by solving for X. So now it's going to be X equals 10 minus 2Y. So what I want to do is isolate X by itself. Now, how I did that, let me just show you. So where I got X by itself is I went back to equation 1 and I said it was X plus 2Y. Remember, I told you in solving algebra, it's always about the opposites. So the opposite of adding 2y is to subtract 2y. And I'm going to do that from both sides. That's how we got back down to here, to this new equation 1. So I name my equations 1 and 2 so that when I change them, I'll know they're still the same equation. So I just rearrange equation 1. Now it's x equals 10 minus 2y. Now I'm ready to substitute, because x is the same as 10 minus 2y. So now when I go back to equation 2, now we're coming back to equation 2, I can substitute. Notice equation 2 has 2 variables. It has x and it has y. They're not like terms. So to make them like terms, I'm going to substitute this x in equation 2 with this 10 minus 2y, because I know x is the same as 10 minus 2y, so I can use the substitution method. So what we get now in equation 2 is going to be 6 times, I take out the x, I put in the 10 minus 2y, right? Still, plus the 5y equals 2. So here is, in purple, here's where the substitution took place, right here. I took out the x and put this in its place. All right, now I'm going to move over to the left a little bit here. Hope y'all can follow this. Another name I have for substitution method is called the stunt double. So I live here in Los Angeles, so we make movies here in Hollywood. So I always use the stunt double rather than substitution method. So the stunt double means this. If I'm making a movie, we don't want the star of the movie to get hurt. So the star of the movie does their acting, does whatever. When it comes to the scene where the house blows up, you take the star out and you put in the stunt double, which is the person who's actually going to blow up. After they blow up, and you take them back and you put the star back in. So it's the same with this substitution method. It's the stunt double. In equation 2, we had 2 variables, x and y. We need the same variables. So I put the stunt double in of the 10 minus 2y. I put that in for x. Now we can finish the explosion. All right. And that's where we are right here. So now that we're here back to equation 2, we can go ahead and solve equation 2, or simplify equation 2. So when we distribute there, we get 60 minus 12y plus the 5y equals 2. Now, like we talked about before, combining like terms, I see this is a y, that's a y, I can combine those. So now, here we go. We have a negative 12y plus 5y. Somebody in the chat, tell me, what do we get from there? What is negative 12y plus 5y? I see a negative 6. That's close. Negative 6 is close. Ah, Tracy, Cameron, I see you with the negative 7y. Very good. So now we get 60 minus 7y equals 2. Perfect, perfect. Good job, everybody. So now follow me in the interest of time here, because I'm trying to just give you an idea of the substitution method. So right here, now I'm going to take some creative license here. All right. I see you in the hall. Y'all good? So now we're solving for y. So I'm gonna come over here and let's just say, this is not a fact, I'm just making this concept easy for you. So we know that if it starts off with just a variable, we can isolate that variable by itself and then put the stunt double in, and then we solve for the other variable, in this case, y. let's say, we're just going to say that y equals 2. Obviously, this is something else, but I'm just saying for argument's sake, let's say we got y equals 2. Now we take that y equals 2 and we plug it back into equation 1 to solve for x. Because it says that x equals 10 minus 2y. So that means that x would equal 10 minus 2 times 2 if we said we found out that, that y was 2. So now we have 10 minus 4, which is 6. So now we would have x equals 6. And then the most important part, I want to show you how you write your answer. You write it as an ordered pair, 6, comma, 2. So what we're saying here is that the x value we have is 6, the y value we found is 2, and that's a point. And what does that mean? That means this. Each of these equations, equation 1 and equation 2, will give you a line. Let me get some room here real quick. We don't need that person there. There we go. So we know that equation 1 is going to give us a line. And then we know equation 2 is also going to give us a line. So this point here, the point where they intersect or cross, that is the solution to the system. And that would be the point 6, comma, 2. So anytime you find a solution to a systems of equation, it's where the two lines intersect. Where do they meet? That's what that point is. So one more quick review of the substitution method. You first look at your two equations, see if one of the equation has a variable all by its lonesome with a coefficient of 1. Then you solve that equation to get that variable alone. In this case, we got x alone. Then whatever x equals, that's our stunt double that we place into the second equation so that we can have the same one equation with one variable. In this case, equation 2 had the 2y and the 5y. Then we simply solve for y, right? We made up in this case that y equals 2. Then you take that value and you plug it back into the original equation 1 to find the other variable, in this case, x. So we got y was 2, then we plugged it back in here to get x was 6, and then that gave us our ordered pair 6, 2, which represents where those two lines cross. Bingo, that's our substitution method. So now I'm going to go to another page and we're going to look at the elimination method real quick. But before I do that, let me stop sharing for 1 second to see if there's any questions. Okay. So real quick, are there any more? Does anyone have need to raise their hand? They have a question on the substitution method before we go to the elimination. Okay, I do not see any hands thus far, so I'm gonna roll on over to the elimination method. Oh, hold on, let me get a new page here. So now we're going to look at the elimination method. So elimination and substitution both work. It's just a matter if you see a variable that's by itself with a coefficient of 1, I would jump to the substitution method if possible. So now for this one here, we have a 3x minus 4y equals 5. The second equation will be 6x plus 2y equals 1. So for the elimination method, the first thing you want to look at is you look at all the coefficients. None of them have a coefficient of 1. That would tell me automatically it's time to go with the elimination method. So here's what you have to know about equations. Here's what you can do. If you have equations, you can add, subtract, multiply, or divide. As long as you do the same thing to both equations, same thing to both sides of an equation, it's still equal. So if I have that 3x minus 4y minus 5, I can multiply both sides by some number and it would be the same. I can even divide both sides by some number and it would be the same. Now here's the fresh dope part about this. You can even add equation 1 plus equation 2, and they would have a baby called equation 3. Bam, you didn't know we had biology and math, did you? Exactly. So if you add 1 and 2 together, they have a baby called 3, but we'll get to that in a second. So just know to use to use the elimination method, you can manipulate each equation and then add the two equations together to give you an offspring, which would be equation 3. Now remember, here's the goal. Here's the goal for this. We have 2 variables and 2 equations. The 2 variables are x and y. We have the 2 equations. Our goal is to get 1 variable and 1 equation so that we can solve it. So this is the goal for the elimination method. You always start out with 2 variables and 2 equations. Then you want to manipulate it, which I'm about to do, so that you come down to have 1 equation with 1 variable, and then we can solve. So let's look at this one. So what I first look at is I look at the coefficients of x and x. I want to see if I add these 2 equations together, I'll need one of these to be eliminated. So you have to choose, and it's up to you, whether you want to eliminate x or you want to eliminate y. It's up to you. So I'm going to stop sharing. Look at this. Oh no, let me just keep going here. It'll be easier. So we have to eliminate x or eliminate y. So in order for me to eliminate one, if I add some number plus another number to eliminate it, means it has to equal 0, which means these numbers have to be, one has to be positive and one has to be negative. So in the elimination method, I'm always looking for coefficients that are multiples of one another, and one's positive and one's negative. So if we look here at the x values, we have a 3 and a 6. So I can multiply equation 1 by 2, and that would make this a 6. But then 6 plus 6 would be 12. We don't want that. So one option, so option 1 is we can multiply equation 1 by negative 2. If I multiply equation 1 by negative 2, this will be a negative 6x, and this is a positive 6x. So when I add these 2 equations, it would go away. That's option 1. And I know some of you are already looking at option 2. Option 2, I see that this is a negative 4 and this is a positive 2. So they're already opposite signs, so I can just multiply equation 2 by a positive 2. So if I multiply equation 2 by 2, that would give me a 4y, and I know the negative 4y plus the 4y would cancel. So either one doesn't matter. In this case, for this one example, I'm going to take option 2. So once again, I want to make sure, okay, hold on a second. I see a hand raised. Hold on a second, Abigail. I see. I'm just trying to figure out how to get back to you real quick. Where is your hand, Abigail? It was raised. Now I don't see you, Abigail. Okay, hold on to that question. I'll come right back to it, Abigail. Let me clean this up just a little bit here. There we go. So now you always want to make sure that you name your equation. This is probably the most important step, that you name this equation 1. You name this one equation 2, and you keep that name everywhere you go. Let me show you why. So now we're going to try to eliminate y. So I'm going to rewrite equation 2 because we said we're going to multiply equation 2 by 2. So here's how I write it. Your teacher may do it a little different. I do it out here 2 times. That lets me know I'm multiplying this 2 by everything in equation 2. So now my new equation 2 will be 12x plus 4y equals 2. Because remember, I can multiply or divide any equation by any number as long as I do the same thing to both sides. So now our new equation 2 is right here. Now I'm going to rewrite equation 1 back underneath it just to keep it fresh and clean, no caffeine. This is going to be a 3x minus 4y equals 5. So now here comes the crazy part. I know I hope you guys are of age. So now equation 1 and equation 2, we're going to add them together. We'll put moms and dad together, and they're going to create a baby, and that baby is going to be named equation 3. So now 12x plus 3x is 15x, and then the 4y and the minus 4y cancel. That's the whole name of the elimination method. It's just for this one step. The name elimination method came from this one step here because we're eliminating y. And now we have the 2 plus 5 is 7. So now remember, we had 2 equations, 1 and 2, and 2 variables, x and y. Now that we added them together and eliminated the y, now baby 3 here, baby equation 3, is simply one equation with one variable, 15x equals 7. Now we can solve this one, obviously by dividing both sides by 15. So now we know that x equals 7 over 15. And now we're halfway done with the problem. So now we need to go back and find y. So I look at equation 1 and equation 2 and say, now which one of these do I want to plug in 7 over 15 to? Do I want to plug into equation 1 or 2? It doesn't matter. You can use equation 1 or equation 2. For me, I tried to use the KISS method, which you should use in math. The KISS method means keep it simple, stupid. So always use the simplest, easy numbers so you don't make stupid mistakes. So the KISS number I'm going to choose, I'm going to actually choose equation 1. So I'm going to go back into equation 1 and plug in that value. So it's 3 times x, which we found to be 7 over 15, minus 4y equals 5. So now we know that 3 goes into 15 most of the time, 5 times. So we have 7/5 minus 4y equals 5. So now what we're going to do is now we have to solve for y. So I'm not going to go through the whole method here because we're running out of time, but in order to solve for y, obviously we can move the 7/5 to the other side by subtracting it from both sides. Personally, I'm not a fan of dealing with fractions, so another thing you could do here is simply multiply both sides by the denominator of 5. If we do that, and we distribute this 5 here and here, that would give us 7 minus 20y equals 25. Then, okay, I'll go ahead and finish up. Then I'll just subtract 7 from both sides, and we'd have negative 20y equals 18. And then simply divide both sides by negative 20. And we get y equals negative 18 over 20. And for my real math heads out there, you know you have to reduce that. But now we have x and we have y. And just so y'all don't call the math police on me, let me go ahead and get this right for you real quick. So the answer would be the ordered pair of x, which was 7 over 15, comma, y, which is negative 18 over 20, or you can reduce it. And this would be the final answer. So this is the point where those two lines intersect. Right there. Bingo. All right, so let me go back and see if there's more questions before we go on to the next concept here. All right, I still see a hand raised, but Abigail, I'm looking, I don't see how to, I don't know why it's not showing. Oh, there you are. Ooh. Oh, it was Angeline, there we go. Angeline, you had a question.
Yeah, okay. Can you go back to your whiteboard thing?
Yeah.
Okay.
Bingo, okay, yes.
So when you did 3x minus 4y is equal to 5,
yep.
Can't you just do negative 4 times 2 and then negative 4 just 4 times 2 on the bottom?
Yes, you can. You can do the negative 4 times 2. That's a great question. So you can do the first equation. Let me pick another color here. Let me do this green. We could have said 2 times that one, and then you could have said 4 times this one, because then you would have had a negative 8 here and a positive 8, and they still would have eliminated. Yes. But what you should consider is that you want to try to do the least amount of work possible. So if I can multiply this 2 by 2, so the 4 cancel with the negative 4, then there wouldn't be a need to do this other 2 up here. But yes, you can do it. But let me show you one more part here. That was a good question. So hold on one second. So if we had something like this, we said 3x minus 7y equals 1, and then a 5x plus 8y equal 9. Here, the 3 and 5 don't go into the same number, and the 7 and the 8 don't go into the same number. So then that's when I would use the method you just talked about. So, Angeline, would you want to get rid of x or y? Which one would you want to get rid of in this example?
Y.
Y, okay. To get rid of y, what will we need to multiply equation 1 by?
8.
Perfect. You multiply that one by 8, and then you would multiply equation 2 by what?
7.
Perfect. Then that will work, because then now for equation 1, you're going to get a negative 56y, and then the equation 2, you get that positive 56y. And when you add them together, that's when it would cancel. So that was a great question. So when they don't go into each other, then you want to multiply each one by some factor so you can eliminate one of the variables. Does that make sense, Angelina?
Yeah.
Cool, good job. Alrighty, so Okay. All right. So now let me go back to the list and see if it's 5 o'clock. I'm gonna see if I can get one more concept in here for us real quick. Um, Factor by grouping. Okay, I saw that one. There was one more. I think we can get in real quick. Okay, I think maybe factor by grouping might be the next one. Let me see if we can work that magic real quick in here. Factor by grouping. Okay, boom. Who answered that one? Ryan. Okay, my man. Okay, Ryan. We'll go ahead and do that factor by grouping. Let me go ahead and get back to the whiteboard. Okay. So one thing, first of all, factoring. Just so everyone knows, for those who taken Algebra 1 and soon be taking Algebra 2, factoring is one of those 80-20 rule skills you have got to master. It takes some work in the beginning, but once you know how to factor, your life will be easy, breezy, bo sheezy. So before we get to the by grouping, here's the type of factoring you need to know how to do. First of all, GCF. Oh, my groceries. You really got to know this. You need to know how to find the greatest common factor. And then when you find it, you need to know how to pull it out. That will always simplify the problem. And then you need to know how to factor this way into the product of two binomials. So say, for example, x plus 3, x minus 6. So you need to know how to do it to where you can factor into the product of binomials. And that's when you have something that's like x squared plus bx plus c. And then when you get real crazy with it, then you have to be able to factor when it's ax squared plus bx plus c, where a is not 1. And we can do some of those next time if you like. And then also, like you said, factor by grouping. So by factoring by grouping doesn't happen a lot, but the thing here is when you have 4 terms. When you have 4 terms, that's your indicator that, uh-oh, I need to factor by grouping. Because typically, when you're factoring, it's going to be a trinomial. It's going to have 3 terms. But whenever you see 4 terms, that's your clue that I should be doing factoring by grouping. All right, so let me see if I can make one up here real quick. These are a little trickier on the fly. Let me see if I do something like a 3x plus plus 8y plus 15 . Okay, I'm trying to make this up. Solving is much easier than actually creating the problem. So plus 40. Whew, let me see if I can do this one. Hopefully this will give me something I can do. So here we go. So here we see we have 4 terms. 1, 2, 3, 4 terms. So what you want to do is you want to group 2 and 2 so that when you pull out the GCF, which we talked about here, you're left with the same factor. So let me show you. So for this one here, I would group the 3x plus 15 plus, then I'm going to group the 8y plus 40. So I took the 2. So obviously the ones would have different variables, x here and y. I would definitely not group those 2 together. So to keep them separate, then I just figure out which constant do I want to put with each so that I get the same factor remaining after I pull out the GCF. So looking here, the GCF here would be 3. So if I factor out the GCF 3, it's going to leave something. And then here, the GCF here is going to be 8. I factor out the 8, and it's going to leave something here. So you know that you have it correct when you factor out the GCF, and what's left on the inside here matches. So when we factor out the 3, we get an x plus 5 in here. Oh, hold on a second. Make the life easier here. Boom. So we're going to make these one variable, x and x. So then here, when I factor out the 8, it's going to leave x plus 5. And so now that we see that these both have the same factor here, now what happens here, I should have put another variable in here. Here we go. So just for the concept, now we both have an x plus 5 in here. So we say, okay, x plus 5 is a common factor, and what goes in the other factor are these coefficients. In this case, it'll be the 3 plus 8. Now, normally you're going to have a variable in here, but for the sake of this one on the fly, we could just see that you group 2 and 2 here and here. You factor out the GCF for the 3x plus 15, it was 3, leaving x plus 5. For the 8x plus 40, we factor out the 8, leave another x plus 5. So the GCF again is x plus 5, which we put here. And then the coefficients that are left go in the other factor. In this case, it's 3 plus 8, which is 11. But typically, this is going to be something with a variable in it. But this is how you would group a factor by grouping. So you're going to have 4 terms typically. And then you have to group 2 and 2 with 2, and then the other 2, and then factor out the GCF so that what's left matches. All right, if you want to see some more of those, then we can try some of those next week as well. So that's our time for today, everyone. Hopefully everyone got something out of this. Please, like I said, let me put up my email address one more time to make sure that if you have questions or problems, send them to me ahead of time, and I'll have them ready for you all. In fact, let me type my email address into the chat real quick. So there is my email address, ljmathman@gmail.com. Feel free to send me some problems for prep next week. I hope you guys enjoyed it. I really enjoyed working with you guys. You asked great questions and gave great feedback. I appreciate it very much. And like I said, when this is over, I will send the link so you can go back and rewatch. All right? Take care. Tell your friends and family to tune in next Tuesday. Let's knock out some more of this math. And remember, all of you guys are mathematicians. Peace out. See you guys next week.